everyone, welcome back to my YouTube channel. So today we are going to solve day 25 problem of this month on LeetCode. Before starting, if you guys haven't subscribed to my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 1015. Smallest integer divisible by k. So in this problem we have given a positive integer k. You need to find the length of the smallest positive integer n such that n is divisible by k, right? And n only contains the digit 1, right? And we have to return the length of n. If there is no such n, then in that case we have to return -1, right? So here if you see example number 1, right? So if I take my n is equal to 1, so 1 is completely divisible by this k, right? So we are just going to return the length of this. So length of this one is nothing but 1 only, right? Clear? Now here if you see this example number 3, right? Example number 3, so k is equal to 3, right? So this number is divisible by 3 or not? Completely no. So next time take this as the new number. So this number is completely divisible by k is equal to 3 or not? No. Next time take this number. So this number is completely divisible by 3 or not? Yes, right? This number is completely divisible by 3, right? 3 into 3, 9, and here 2 and then 1. So here 3 into 7, right, is 21. So we are going to get remainder 0, right? So 37 into 3 is nothing but 111, right? So this number is completely divisible by 3, right? And what is the length of this number? Length of this number is 3. So this is our output, right? And if you see, these are the constants. So k value, it can be from 1 to 10 raised to power 5, anything, right? We have to find the smallest number n, right, which is completely divisible by k, right? This is the requirement, right? Okay. Here if you see this example number 2, right? So tell me, can any number, right, in which we have like this 1 in the end, right? They are all are odd numbers only, right? Can these numbers be divisible by 2 completely? Never, right? These numbers are never going to be completely divisible by k is equal to 2 value, for 2 value, right? So in this case we are returning -1, right? There is no such positive integer n divisible by 2, right? So so same way, right? So I can simply say, right, I can simply write one base condition in my code, right? If my k modulus with the 2 is equal to 0, right? If my k value, right, is completely divisible by 2, then we will always going to return -1, right? Because all these numbers, if these numbers are not divisible by 2, definitely these numbers are never going to be divisible by 4, 6, 8, 10, 12, 14. Reason is because this 4 you can write it as 2 into 2, this 6 you can write it as 2 into 3, this 8 you can write it as 2 into 4, right? Or 2 into 2 into 2, right? 2 into 7. This 12 you can write 2 into 6, this 10 you can write 2 into 5, right? So if you see in all these numbers, right, in all these numbers, right, there is one factor 2 involved, right? And if factor 2 is involved, that simply means that these particular number are never going to be completely divisible by k, right? So I will just, if I want, I can simply write one base condition, right? If k modulus with the 2 is equal to 0, right? If the number is divisible by 2, right? If k is divisible by 2 completely, then it is impossible to form with only ones, right? Same way, if you see the 5 multiples 5, 10, 15, 20, 25, 30, 35, right? So even if my k is completely divisible by 5, right? So here I can add one or condition. if k modulus with 5, right? If it is equal to 0, then also in that case you have to simply return -1, right? If you want, you can add this, right, for early exit, right? Not necessary, but if you want, you can add this line. Okay. For other numbers, if you see 3, so with 3 it is possible, right? 4, I already told you, 4 is if your k is equal to 4 na, so 4 modulus with the 2 is going to be 0 only, right? So in that case we can just do simple early exit. With 5 also you can do early exit. With 6 also you can do early exit. With 7 can we do early exit as of this condition? No, I don't think so, right? With 7 we can't do early exit, right, with this condition. 8 we can do early exit. With 9 we can't do early exit, right? So here if you see, if you want more numbers, right? So for 9, if you take this number 1 1 1 1 1 1 1 1 1, right? So I think this number is completely divisible by 9, right? You can try now. If you see the 9 table also, like this na, 9 table. So here if you see sum of digits, 1 plus 8 9, 2 plus 7 9, 3 plus 6 9, 4 plus 5 9. This is how we write a table, right? Or 9. So here also I just apply the same logic. So if you just add all these numbers now, so these all numbers will give you 9 only, right? And if you want, you can divide it. Okay, so 9 1. So here you are going to get remainder as 2. So 9 2 18. So here 3. Here 9 3 27, 4, 9 4 36, 5. After that 9 5 45. So here 6, and here 9 6 54. So 7. So here after that 9 7 63. So 63, and then 8, and here 9. So see, so if you do 9 into 1 2 3 4 5 6 7 9, you will get this number. Okay, so with 9 I think smallest length will be 9 only, right? So this I proved. Okay, but k can be anything na. K can be 10 11 12 13 14 until 10 to the power 5, right? It can be anything, right? So instead of checking like this, right, instead of forming a number like 1 by 1 1 1 1 1 1, so in this way you are going to search, right? If you're say, let's say your k is 9, so in this way you are always going to append 1 1 1 1 and then check side by side that if it is possible with 9, if it is possible, and you continue. It is a never-ending process. If you just apply this logic, add 1 every time until the number is completely divisible by k, right? We have to stop somewhere, right? We have to stop somewhere. So how we are going to find out where we need to stop, right? So let me give you one example here. Let's take example of k is equal to 7, right? So first, this is a number, right? 1. So 1 modulus with 7, I'm going to get a remainder as 1, right? New number, how I'm forming? I'm forming number like this now, 1 into 10 plus 1. This is nothing but 11 only, right? And 11 modulus with the 7 is nothing but 4, right? Am I right? 8 9 10 11, yes, right. So after that, new number is nothing but 11 into 10 plus 1, that is nothing but 111, right? So this is how I'm adding a new number such. And 111, 111, if you divide it with the 7, so what you are going to get? 7 into 7, 4 1 7 5 35. So here you are going to get remainder as 6, right? So here add 6, done. Okay, next time new number is 111, right? Into 10 plus 1, you are going to get 1111, right? So now 1111, and here if you divide it with 7, what you are going to get? 7 into 1 is 7, right? 4 1 7 5 35. So you are going to get 6 here, and here 1 7, here we need to apply something. 7, what is 7 into 8? 7 into 8 is a 56, right? So I'm getting what? 5. I'm getting 5, right? Correct? I hope I'm correct. Okay. And after that, new number is 111 into 10 plus 1. You are going to get what? 11111. Okay. For this one, what is the remainder? Let's see. 11111. So 7 into 158 is nothing but you will get a remainder as something around 5, right? If you just take the previous example. So until here 5 is there, right? And then again 1 come. So 7 6 42, 7 7 49, right? 7 into 7 is 49. So you are going to get 2, right? So 2 as the remainder. Okay, this is correct now. 1587, if you just multiply it with 7, 7 into 7 is 49. So much maths I'm doing. 8 7 56 60, 7 5 35, 35 6 41, right? And 7 1 7, 8 9 10 11, right? So here see 1 1 1 0 9. So 2 is the remainder, correct only. Okay, but actually I want to prove here, so that I need to actually show here. All right, so after that, new number is 11111 into 10 plus 1, that is nothing but 11111 and again 1, right? So this is a new number, right, in which you have 111111, and if you divide it with 7, right, so what is the remainder you are going to get, right? So that's what we need to check. So here last time it was 2, right? I can shortcut apply, right? So 1587, so we were getting some remainder as 2, right? After that we have one more one. Okay, so now 73, what is 73? 73 is nothing but 21, right? 73 is 21, right? This is what I'm getting, right? So here remainder is 0 now in this case. Okay, remainder is 0, so we are finally getting 0, right? With 7, answer is possible for this particular number. And what is the length of this? Length of this one is 1 2 3 4 5 6. Okay, now after that, here if you notice one thing, we are going to get a remainder is equal to 0, right? Remainder is equal to 0. Then during this time we are going to get the number which is completely divisible by our k value, right? K value. Now that simply we have to stop here. This is the one point, we have to stop here. Okay, but let's suppose you didn't stop here. You didn't stop here. Again you added one more one, right? Again you added one more one, right? So then your new number will be like this: 1111111, and again one more one. So in this you are going to get the remainder as 1, right? After that again you add one more one. Okay, 1111111 and two ones. Okay, so now this time again remainder is going to 4, right? So now if you notice, again if you add one more one, 3 1 3 1, one more one. Okay, so now 4 1, so 7 5 35 6. So here again cycle is repeating actually, right? So you will see the same cycle, right? You will see the same cycle. Okay, so if you are not going to write this piece of code, right, for early exit, then also it is fine, right? Then also it is fine if you are going to see the same cycle again, right? So like here, when do I need to stop actually? So I need to stop here when I'm going to start from 1. Let's say this I is equal to 1, this I is equal to 2, this I is equal to 3, I is equal to 4, I is equal to 5, and I is equal to 6, right? I is equal to 6. I is equal to 1 2 3 4 5 6, right? And after that I'm going to see the same cycle again, right? I'm going to see the same cycle again and again, right? So only until here I need to do my calculations, right? Only until here. After that I can actually stop, right? I will see the same thing. Let's prove it with some example. K is equal to 3, right? K is equal to 3. It's a very easy example, this one. K is equal to 3. So first time your number is like this, remainder is 1, right? Next time your number is like this, your remainder is 2. Next time your number is like this, your remainder is 0, right? Next time your number is like this, 1 1 1 1, right? So again it is going to be 1. Next time your number is like this, 1 1 1 1 1. So again your remainder is going to like this. So you will always see the cycle. You will always see the cycle, right? So here again 0, it is again 0, right? So you will always see the cycle, right? So if I run my loop for I is equal to 1, I is equal to 2, and I is equal to 3, right? 1 2 3. So here also I is equal to 1, I is equal to 2, I is equal to 3. So let's run it for less than equal to k, right? So here even with 6 our result is possible, right? So it is 1 2 3 4 5 6. So let's do one thing, let's run it for complete until k, right? Because if I run until k now last time, right? So after that again cycle will repeat. If you take this, consider this example, k is equal to 3. So here my I is running for 1 2 until k, right? Here if you see in this case my I is running less than k, right? Like less than k, if you see with 6 answer is possible, but let's run it until here, right? Because here if you see this example, it is possible here, right? So we are planning to do at most k iterations before remainder repeats, right? Before remainder repeats. So that is my plan. Okay, so that is why I am running my I loop for less than equal to k, right? As you see here, right? And definitely if your k value is equal to 6, right? If you pick any number, if you pick any number, right? 1. So for 1 remainder is 1, for 2 remainder is 2, for 3 remainder is 3, for 4 remainder is 4, for 5 remainder is 5, for 6 remainder is 0. Same way 7, 7 modulus with 6 remainder is 1, 8, then 2, then 9, 3, then 10, 4, then 11, 5, then 12, again 0. So this cycle actually will repeat, right? So we will, for k is equal to 6, we will only see the remainders as 0, 1 2 3 4 5. In this example k is equal to 3, right? So 1 2 0. So I have seen all possibilities here, right? After that I will see same thing, 1 2 0, right? Here if you see 1 4 6 5 2 0. Okay, so I have seen all the possibilities here, right? Clear? And then after that it is again going to repeat. I will not get anything new after that. Okay, it will still showing me same only, right? So this is the plan actually, right? So if you are not writing this base condition, if you are writing this base condition, then enough. Then I don't think we will ever reach to the point where we have to return -1. Okay, because we are only running our loop for I is less than equal to k, and if in this, if my remainder becomes anytime 0, then I can simply return. Okay, and here if you notice one more thing, so 1, right? Number is 1, right? So here let me use some other pen. Okay, let me use green here, right? So here 1 modulus with k is nothing but equal to 1 only, right? Clear? Clear? Now this time remainder is 1, right? Instead of picking this complete, what I'm doing, overall remainder, I'm picking this overall remainder, 1 into 10 plus 1, and then I'm doing modulus with k. So I'm going to get 4. I'm picking this instead of this number, I'm picking this 4 into 10 plus 1 modulus with k. So 40 plus 1, 41, and 41 modulus with 7 is what? 41 modulus with 7, so 7 5 35. So I will get 6, right? 6. Here I am saying 6 into 10 plus 1, right? Modulus with k. 61 modulus with 7, 7 8 56. So I will get 5. So this also I can do, right? Because here this, instead of doing this, taking this complete number, I can easily pick the remainder, right, of this one, right? And I just need to multiply it with 10, right? So this 4 this 4 remainder of this, right? This 4 is nothing but remainder of this. So in this remainder only, if I multiply 10 plus 1, I will get a new number, right? Okay, so here what I'm saying, 1 modulus with k, let's say 7, right? So 1 modulus with 7 is nothing but 1, right? And after that, 1 modulus with 7 is nothing but 4, and after that 1 modulus with 7 is nothing but 1 here 7, 7 7 here 4 1 7 5 35. So you are going to get 6. Okay, 6, right? So here this number is very large, right? This number is maybe very large. In future you may see something like this. Okay, so and this number is nothing but, this number is nothing but 10 11, this previous 11 into 10 plus 1, right? This is how we are forming, right? This is how we can write it, right? 11 into 10 plus 1, right? Same way this thing I can write it like this, 11 uh, 11 into 10 modulus with 7, right, plus 1 modulus with 7, and this overall modulus with 7. We can write it like this also. So 1 modulus with 7 is nothing but 1 only, and here you can also write it, just change the order. This is how, and overall modulus with 7, this is also you can write. And 11 modulus with 7 you already know, it is nothing but 4, right? So here that is nothing but 4 into 10 plus 1, right? 4 into 10 plus 1 modulus with 7. So we are just taking the modulus with 7 only, right? We are only dealing with the remainders. So 4 into 10 is 41. 41 modulus with 7 is nothing but, right, here 41 modulus with, right? So this is a plan, right? This is a plan. And even though if you see this, if you see this particular thing, right? So 1 1 1 7, right? 15. But this subset, this tree, this this is a new thing, right? Until here we have already solved, right? Until here we have already solved, and this is nothing but 4 into 10 plus 1, right? And this is the only part that I need to solve further, right? If new 1 is coming, right? So 41, so new 1 is coming, so I can write it previous 4 into 10 plus 1. So instead of again starting from here, I can simply start from here now. 4 was last time, and into 10 plus 1, right? So now it is easy, right? Why I'm doing like this, clear? So this is the reason actually, right? So that's it. This is why I'm writing like this here. Okay, I can write it like this, right? So now let's write the code, right? It is very simple. Okay, so here first thing you can do one thing, create int remainder and is equal to 0, and here length you can create equal to 0. Then I told you that we have to do at most k iterations, right, before remainder repeats. All right, and here I have to just simply write for int I is equal to 1, I is less than equal to k, and I plus plus. Okay, so here how I'm going to operate the remainder, it's nothing but remainder into 10 plus 1, right, modulus with k, that's it. And here length plus plus, and here if your remainder, if it becomes equal to 0, then in that case you have to return length. Okay, so here I will write this, let's say return -1. Okay, I will say. Now if I run it, solution is empty, right? Let's submit it actually, right? All the test cases are passed. Let's submit it. So our solution is also accepted, right? Okay, now here for this one, if you see, we are only running one loop until k, so you can say of k as the time complexity, right? Let's do little twist here. Let me add here, instead of -1, let me add 200. So now if I run it, so this test case is failed now, right? This test case is failed, and last time I'm adding 200 only, right? Here I'm adding one more base condition. If k modulus with 2, if it is equal to 0, or if my k modulus with 5 is equal to 0, then in that case just simply return -1. Early exit. I'm doing early exit. Okay, I'm doing early exit. Now if I run it, this test case is passed now, right? Now can all these empty test cases will be passed or not? Let's see. See, all the empty test cases passed again. So we never reach here, right? We never reach here actually, this 200. Okay, so here just for better coding practices, you can write -1, okay, instead of 200. That I'm just showing it that we never actually reach here to 200 if I'm writing it here, right? So you can try one thing, right? So you can, maybe that particular test case is not here, you can try finding any k value in which I'm going to reach here. I'm going to execute this -1 instead of above -1 in early exit. Okay, so try if you can find anywhere I'm going to reach to this -1. Okay, so this is a code, right? So if you don't want to do early exit, then still it is fine. Okay, so that's it. So this is what you need to do, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in the comment section. Till then, keep coding and keep practicing. Meet you guys next video. Thank you. Bye bye.